Hello, good evening. Today I am going to present my project on fog enabled precision agriculture. It is mainly focused on real time crop and equipment, which is monitoring using the gyroscope, accelerator, and proximity sensors. Now, here we can see the introduction like why is fog computing? Because it moves computation power closer to data source where it process data locally edge or fog sends only important data to cloud. And mainly we can say that in this project the precision agriculture uses IoT for granular field of data, and it has a high volume, velocity, and variety. And mainly, I have inspired by the Malik, which was the paper published in the year 2024 by Mr. Malik. And the main objective is the fog-based architecture for crop and equipment monitoring. Here, the challenges like latency, bandwidth, connectivity in cloud-centric IoT, which we are going to see in this project, and the fog and edge computing process data closer to the source in our mission. And mainly the proof of concept is I'm using the iFog Sim simulation plus Python and as well as AWS IoT core. And at last we will be seeing the results. The critical analysis has been analyzed with the simulation process and where it is gone through big data handling in stream processing at edge and where it is getting aggregated through at fog. And here is the wireless technologies with the sensor edge and Wi-Fi with the edge compute edge fog and with the broadband with the fog cloud. And as well as we can see the service distribution like each layer handles very appropriate workloads. And this is the architecture where I have implemented this project very clearly. Like in this, we are having a 4 layers and 4 IoT device layers and the sensors I'm using like gyroscope, accelerator, proximity, and actuator, which are having emergency alert and as well as a health notification. In the edge layer, immediate processing thresholds checks and sends filtered data to fog. And where as well as the fog layer is having correlates data, triggers local notifications and sends critical anomalies to cloud itself. Where for the cloud layer, it having deep analysis storage where the machine learning model can be trained and be retrained also. And we can see next the data flow. Here it is in the form of the upstream process like IoT edge, fog, and cloud of log. In the IoT, there we see the raw sensor data and as a basic processing. For the edge, you can see the process data correlation and as well as analysis. For the fog, it has a critical data and as well as data analysis, machine learning. With the cloud, we are having controlling of the commands and the technologies I have used is I already told you like iFoxim, Python, and AWS, which we are going to see in the upcoming minutes. And these are the performance metrics, which we can see in the last of the results in the implementation process. And we can see the final conclusion in the later part. Like now I will show the code. Then this is the iFoxim. This is the iFoxim where I have implemented through in the Java process. And these are the results of the iFoxim. Like here you can see the results, the execution time, and the accelerometer proximity the values. Here we can see the energy consumed for the each and every part and total network usage. And this is the Python code. This is a Python code which I have used for the AWS simulation process. I have used the Boto3 JSON and I have loaded the AWS configuration, the configuration through, and I have used every sensor in it and every part. It has a clear sensor mentioned like gyroscope, accelerometer, proximity, and also the performance matrix also given as per this execution. We can see the simulate accelerator responses through in this part and the run precision. And here everything the step by step I have implemented clearly by the as well as health analysis process. And also here we can see that this is the execution part where it has been given, and after giving every point I have got the output with the giving AWS key access access key and as a secret key. And these are the iFox in Java implementation with AWS IoT integration. And I have used the sensor like gyroscope, accelerometer, and proximity as I already told. Like here is the edge processing, fog analysis, and the cloud processing. The actuators are emergency alert, and health notification. The expected delays like critical health loop with this milliseconds and routine monitoring loop and the sensor transmission type of with these seconds. And these are the unit for the energy consumption, and the testing is done and the simulation is done with the different process, and you can see that different data will be calculated for every different simulation cycle. There is a raw, these are the mainly parts which is getting executed, but the issues has been changed for the every simulation cycle. Here we can see the health analysis as one issue and level as a medium, and whereas we can see the another one like health issues in the simulation cycle 6, there's a one issue and the level is normal. So for every part it will be getting changed depending on the implementation and also depending upon the monitoring. So this is part execution part, and these are the results you will be finding out. And finally, this is the AWS which I have implemented this in the cloud itself. Here we can go to the IoT core, the AWS, which I am heading towards the IoT, and you can see the all devices where I have used this thing, the things. This is my project agriculture edge device, and in this you can see the activity where I have already given here, and this is the code for the gyroscope accelerometer proximity where I have implemented clearly and has a healthy analysis, issues detected, performance, everything is given over here. So as per that, the performance matrix also gets executed, and as per that, these results has been